Hi, I am Shelley, and I will be presenting to you Cloud Technology and Digital Communications, focusing on latency, data packet loss, and quality of service. Cloud technology has transformed the way we communicate, collaborate, and deliver services in today's digital world. From video conferencing and voice over internet protocol to telemedicine and online gaming, cloud-based platforms enable real-time interactions across vast distances. But the quality of these interactions depend heavily on the underlying network performance. That's why understanding key metrics like latency, packet loss, and quality of service is so important because even the most advanced cloud technology can't deliver a good user experience without a fast, stable, and reliable network. Let's dive into what they are, how, and why they matter. Let's begin with the big picture. Why do latency, packet loss, and quality of service even matter? First, they're crucial for real-time responsiveness. When you're in a Zoom meeting or gaming online, you expect your voice and actions to be seen and heard immediately. Even a slight delay can cause confusion or frustration. Second, they help maintain communication clarity. Packet loss or high latency can distort audio, break up video, or cause people to talk over each other. Third, these metrics are essential to supporting critical services. In healthcare, finance, and emergency response, even small delays in miscommunications can lead to serious errors. And finally, they improve overall user experience. A smooth, fast connection leads to satisfied users, but a poor network can cause people to abandon services out of frustration. So these metrics directly impact not just performance, but also business success and user trust. Let's break down the first metric, latency. Latency is the time it takes for data to travel from its source, like your phone or laptop, to its destination, like a cloud server, and back again. Think of it as digital travel time. Several things affect latency. First, physical distance. If the server you're connecting to is across the country or on another continent, it takes longer for data to get there in return. Second, network connection. Just like a traffic jam, too many people using the same network at once slows everything down. Third, routing complexity. If your data has to pass through multiple stops or inefficient routes, it adds to the delay. And fourth, bandwidth availability. If the lane your data is traveling on is narrow or full, it has to wait, increasing latency. The impact of latency is easy to notice. In a video call, someone might respond with a delay. In gaming, you press a button and your character needs a second to react. These are all symptoms of high latency. Next, let's look at packet loss. When you send data over the internet, whether it's a message, a video stream, or a file, it gets broken down into small pieces called packets. These packets travel independently and are reassembled at the destination. Packet loss occurs anytime any of those packets never make it to its destination. It's like mailing someone a 10-page letter and a few pages are getting lost in the mail. The message still arrives, but it's incomplete and confusing. This can lead to distorted audio, missing frames in video, or incomplete downloads. In voice over internet protocol calls, for example, someone's voice may cut in and out. In telemedicine, this could cause a doctor to miss a critical detail during a consultation. Packet loss is often caused by network congestion, overloaded services, or interference in the connection, especially on wireless or shared networks. To help manage latency and packet loss, networks use quality of service or QoS. Quality of service refers to a set of technologies that manage how different types of data traffic are handled in a network. The goal here is to prioritize more important data like voice and video over less time-sensitive information, such as emails or background updates. Quality of service helps in four major ways. It prioritizes critical traffic, ensuring that important services are given first access to the network. It reduces latency and jitter, which keeps real-time conversations and video streams smooth and consistent. It minimizes packet loss, helping to maintain the completeness of data. And it manages bandwidth efficiently, especially when many users are online at the same time. Think of it like a highway system where emergency vehicles get a fast lane. They get where they need to go without delay, even if traffic is heavy. So, how do these issues affect us in real life? Let's look at a few examples. In telemedicine, doctors and patients rely on real-time video and audio to communicate. If there's a lag or dropped packets, the doctor might miss a key symptom or misunderstanding could occur. In voice over internet protocol calls, packet loss can result in broken or robotic sounding speech, making it difficult to have a clear conversation. Video glitches in conferencing platforms like Zoom or Teams disrupt meetings, leading to misinformation or miscommunication. And in online gaming, even tiny spikes in latency can cause delays that frustrate players and make games unplayable, especially in competitive environments. These are not just annoyances, they can impact health, business productivity, and user satisfaction. Finally, it's important to understand that these issues become even more complex in multi-cloud or hybrid environments. Many companies use multiple cloud providers like Amazon Web Services, Microsoft Azure, or Google Cloud to power different parts of their system. This adds flexibility, but also increases variability in latency, packet loss, and service quality. Quality of service becomes even harder to manage across various platforms, each with their own rules and infrastructures. To deal with this, companies use edge computing to move processing closer to users and advanced monitoring tools that track performance and reroute traffic in real time to avoid issues. This kind of intelligent traffic management is essential for delivering consistent quality in complex cloud ecosystems. Now, I will hand off the presentation to the next group member who will present on security challenges in multi-cloud environments.